Yeah, then maybe one thing I would like to mention at the beginning. At some point, I'm probably going to stop the video. I want to really save the bandwidth for sharing the material. I think that is the most relevant. So I think I stopped the video already. So then let me start with the oneAPI introductory slide. So it's talking about a lot of buzzwords, which are also mentioned on this slide. So cross-architectural programming, performance is important, freedom of choice, industry initiative, and the respective oneAPI Intel products. All of these terms going to come up probably multiple times. So let me set the stage here. For some reason, was not moving. So let me start with the problem statement. As Thomas just mentioned earlier, he is interested in heterogeneous environment. The world is going to heterogeneous architectures. So in the past, a lot of people developed their applications specifically using general purpose CPUs, and the x86 architecture, so the Intel architecture, has been very, very successful over the last, I would say, 40 years or so. Has been I mean, probably everybody knows about the x86, I guess, and has been using it for development purposes. Over the last couple of years, new developments have happened in terms of new chips, new architectures coming up for specific needs, which are in use. People are using it, though, and you see that on the right side here of the screen. So beside the CPUs, we have the GPUs, we have FPGAs, we have dedicated accelerators, for instance, for AI. All of these have in common that they have their own programming model, which requires that people who want to switch from architecture to architecture have to not only learn about the new hardware, they also have to learn about new development environments. And that is a costly and timely solution, time-consuming solution, adding a lot of complexity to software development. oneAPI is the approach to simplify the approach with a new model, with an open, standardized model, which offers the freedom of choice for everybody. So basically, the idea is develop once and run the application on with the oneAPI framework on all the different hardware. So and that is what is meant with this block here in the middle, with oneAPI being the link between the applications, the middleware, to the various heterogeneous hardware environments. oneAPI consists of two things, and I'm going to talk in my introductory about the two aspects or the two domains. It is an industry initiative, and their oneAPI also has products, and I will talk about the Intel implementations of oneAPI. Though, having mentioned that, because if it's an industry initiative, anybody who wants to can also develop his own oneAPI implementation, development environment if he wants to. You can jump the bandwagon if you like by using the goods of oneAPI, since it's, as I just mentioned, it's a standard. There are open APIs and descriptions in it which allow people to replicate it for his own environment and deploy it for his own environment. Maybe the last topic I'd like to mention here is on the lower left side here. A core part of the oneAPI concept are the languages. And I'm going to talk about that a little bit more, and Igor going to expand on it very significantly with the necessary details. oneAPI is compatible with the existing languages. So C++, and there are extensions to C++ that we're going to talk about, but oneAPI is also open to other languages and standards which are shown here, which are relevant for program development. Yeah, this slide here goes a level deeper. That consists of the three main elements of the oneAPI initiative and of the standard. One is the direct programming. A core part is the data parallel C++, an extension to the C++ standard, the C17 the version 17, C++ 17. There are a lot of libraries. So for all of us who are developing a lot, one of the golden rules is if you find libraries that have functions that you can reuse, you better think about using them, because people like Intel who are offering these libraries, we have spent a lot of time in order to optimize it for a given hardware so you get the most performance about using libraries. But as I said, the concept is open, so the library interfaces are open. Some of the code is also open and can be used by others for their own implementation. So that's the second part. And the third part is a lower level hardware interface with drivers which are bridging the gap between the programming, the direct programming tools and the libraries to the specific hardware. That is typically something which is available. So any hardware vendor can use it for his own purpose to adopt the higher level software and middleware and the programming tools to the specific hardware. So let's move to the next slide. So data parallel C++ is a standards-based cross-architecture language. It is built on top, and I think that can very well be seen here on the right side. It's built on the C++ standard, the version 17. The Kronos community, which is a standardization body, which has been around for a while. These guys were driving OpenCL, and they're also driving SYCL, an extension of C++, a C++ extension, which is addressing heterogeneous programming. And on top, Intel has added to C++ and the Kronos SYCL implementation additional community extensions. Igor will talk in a bit more detail of them. Some of these extensions, in the meanwhile, have made it to the latest Kronos spec, the 2020 SYCL spec, which was announced in the February timeframe of this year. I talked about the libraries here. You see a little bit in more detail which type of libraries we have in mind and which are part of the standard. So there's linear algebra as part of the math kernel library, but it's not only linear algebra, there are many other functions in there. There are thousands of functions actually in the math kernel library, which are useful for numerical simulation. The second one is a video processing library. So libraries which include coding, decoding, transcoding of video standards like H.265 and others. There is a threading building blocks. That's a template-based library. There are additional DPC Plus library functions which are added to the specification. Deep learning has been on the rise for the last, I would say, 10 years and has become a hot topic, I would say, the last 4 or 5 years. And so the deep neural network library is reflecting that need. So there are a lot of functions in there which are accelerating or can accelerate the performance of specific tasks which are required, in particular in the training side, which is the most powerful or power-hungry element of deep learning training or deep learning. The next one is the data analytics library. That's a library for classic machine learning. So nearest neighbors, decision trees, regression, and other tasks, many other unsupervised, supervised learning. A lot of functions are in there, and which are part of the library. And for those of you who live and work in distributed environments and cluster environments, the collective communications library, the oneCCL, has functions which are supporting or sitting on top of MPI and supporting deep learning, distributed deep learning tasks. Some of this stuff is integrated in respective packages and supporting TensorFlow or PyTorch. In terms of the industry standardization process, here you see the progress on oneAPI. So oneAPI, there's a standardization body that meets on a regular basis. In Q4, the oneAPI 1.0 spec was released. Future specs are coming up. I mentioned the current Kronos release of the C++ language, the SYCL language. This new specification is the 2020 specification, which was released, which actually has a lot of the Intel suggested extensions in there. What I'd like to add here also is there are in the industry activities implementing oneAPI also for non-Intel hardware. So the company CodePlay has developed a solution supporting oneAPI on NVIDIA hardware, and the University of Heidelberg in Germany is delivering oneAPI AMD Discrete Graphics solution. I'm running a little bit behind, so let me skip over that relatively quickly. I mean, it's probably a little bit of an eye chart anyway. So in the meanwhile, after oneAPI have been introduced and launched to the market, a lot of people have an interest in the oneAPI concept, and also has worked with Intel in terms of implementing the solution and supporting the solution. Here are a few examples. Both of them are more on the, I would say, on the AI side. So TensorFlow, known as the Google deep learning framework, very well known deep learning framework. So Google and also Microsoft are supporting the oneAPI initiative and bringing the solutions into their environments. So that was the part of the initiative and the standardization efforts. Let me talk a little bit about the oneAPI products, the Intel products. So on the right side, you see again the kind of layer model that you saw earlier. So on top of the XPUs or the hardware, you find the various Intel products sitting on top, including the low-level hardware interface, which we're using in order to, as I said earlier, bridging the gap between the products and the hardware. So that has been around, has been launched officially in November, and the product became available as a product itself, as a gold product in the beginning of December, on the 8th of December. So let me talk one by one on a relatively high level about the key components. So one element is the DPC Plus compatibility tool. So that's a tool for developers who have CUDA source code, CUDA applications that they would like to port into the oneAPI environment, and particularly using the DPC Plus language. So the compatibility tool basically is a concept and a solution that takes the CUDA code and automatically transforms, by our experience, 80 to 90% of the code into human readable DPC Plus code with inline comments. And it kind of points you also to those elements which could not be ported. And that is something which is then a manual process in order to, at the end, generate the DPC Plus source code. I have here an example from ZIB. I don't want to steal the thunder for the presentation for tomorrow. So this is an application that was using the compatibility tool in order to turn it into a DPC++ application that was running different hardware. We're going to learn more about it. I think the ZIB colleagues are very proud of their solution and the performance gain that they got out of it. In terms of DPC++, I don't want to spend too much time on it. Some of the stuff I was talking about it, DPC++ is based on the ISO C++ 17 standards and on the Chronos SYCL extensions and the Intel DPC++ extensions. With DPC++, Intel is introducing, and we have been working on it for quite a while, on the Clang and LLVM concept. We'll talk in more detail later about that. For a development environment, analysis and debugging tools are very relevant, and we are offering them. For those of you who have used Intel Preiss Studio, some of the names might be very familiar. The Advisor and the VTune Profiler. The Advisor typically has been a tool that was helping on vectorizing application and get the most performance out of it. The Intel Advisor for heterogeneous environments, and specifically for oneAPI, has an additional offering. It offers kind of, I would say, what-if analysis. So it allows you to speculate and get results about what would happen if you would take, let's say, a CPU-based application and turn it into a oneAPI application running on a specific hardware, let's say a discrete graphic. And it will give you ideas about the performance gain that you will get by taking that step. It has a couple of additional features. We're going to learn more about that tomorrow. There's a debugging tool, the GDB, an Intel distribution of the GNU debugger in there for debugging the application. And many of you know the VTune Profiler, a tool that identifies the bottlenecks or the hotspots in applications. Historically, that was for x86 applications. The VTune Profiler now also supports discrete GPUs, FPGAs, plus, of course, the CPU. And it also allows to optimize the offload performance, for instance, when it comes to offloading parts of former CPU code onto, for instance, a discrete CPU. And it supports the languages which we are offering, DPC, or the languages which are on the market. So DPC++, our C++ extension, C, C++, Fortran, Python, Go, Java, and others, since it's expecting the code and the source code. Intel is offering oneAPI commercial toolkits, which come with priority support. Again, maybe another eye chart. I will talk to the individual components on some of the follow-on slides. So there's a base toolkit, there's an HPC toolkit, there's an embedded toolkit, there are rendering toolkits. I'm gonna talk a bit more about it, say a few additional words about it. When I was talking in the introduction about the transition paths, this slide reveals a little bit more detail about it. So you might have been aware of Intel Preiss Studio XE, development environment for ISVs, for HPC people, and there was a parallel product. The Intel System Studio was very much for the embedded market. So Preiss Studio, pretty much all the components, and I have another slide that goes in a bit more detail about that. It shows you how all these components are now part of the base toolkit and the HPC toolkit. So basically, if you have this toolkit, the Preiss Studio XE right now, you can transition with the combined base and HPC toolkit into the oneAPI world. There are a bit more instructions in the slide deck, which will be available to you. It should be available by now. The colleagues from ZIB, as I understood, might have sent out the email, so they can be downloaded, so you can have a look at it. I will not spend time on it, but it's relatively easy. There are some screenshots, what you need to do in order to go from Preiss Studio to the oneAPI. Let me spend the remaining time for the introductory talk about the domain-specific toolkits. And so there is a base toolkit that is required for all the additional domain toolkits. So the base toolkit is common and is required in order to build the others on top. The additional domain toolkit, domain-specific toolkit, consists of the HPC toolkit, which adds Fortran, OpenMP, and specifically MPI. So for those of you who live in the HPC cluster environments, distributed computing environments, the combination of the base toolkit and the HPC toolkit is the solution to go. The embedded developers among you will go for the base toolkit and IoT toolkit combination. Some of you, that's something which is relevant and relatively new, I would say, is the oneAPI rendering toolkit. The rendering toolkits have been around for a while. So this is for rendering, for rasterization, for ray tracing tasks. So Intel has had tools for quite a while for that domain. And we are offering it now under the oneAPI umbrella as a supported tool. And as such, like all the others, they can be purchased. On top, we have a couple of toolkits also powered by oneAPI. So there's an AI analytic toolkit. So in a nutshell, it includes optimized deep learning frameworks like PyTorch and TensorFlow. And particularly for those people, I would say also predominantly mostly on the embedded side, but I've seen also Openvino being used in cluster environments. So that is a toolkit for the inference, for implementing deep learning inference solution. That's basically what it is. And I have an additional slide on it that I'm going to talk about very quickly. Yeah, the base toolkit, another eye chart. So there are direct programming tools in there. So the languages that Intel is offering, a lot of libraries, many of them I've talked about already, and the analysis toolkits that I also talked about. The blue boxes here are the boxes which are added to the light blue ones. So the light blue ones are basically the base toolkits that you saw on the earlier slide, and the HPC toolkit is adding a couple of analysis tools, MPI for cluster solutions and cluster programming and computing, and additional compilers. So basically what we call the classic compilers, so the compilers that you know from the past, which were part of Preiss Studio XE, which are allowing programming on x86 are part of the HPC toolkit. So they are included in the HPC toolkit. This is the same slide again. It's added by one piece of information that you can look at it maybe at your spare time. So everything that is surrounded in a reddish type of box includes the components of Preiss Studio XE. So these are the Preiss Studio XE components, plus the features, of course, which allow heterogeneous programming. But within these, you find all the features that you know from the past, which are supported with oneAPI. So there's a similar block for the embedded toolkits, the IoT toolkit. I'm going to skip over that very quickly. This might be new. For some people, it might be relevant. So in particular, if you want to visualize your solution, for some of you, you might have 3D models that you want to give a photorealistic view. The oneAPI rendering and ray tracing library is going to help. So there are different type of libraries. As I said earlier, so ray tracing photorealistic rendering, there's a denoising library, there is a rasterizer library, and the Osprey, another rendering library. So this is a set of libraries. Think about it. For those of you who do numerical simulation, you might use MKL functions, math kernel library functions a lot. For those of you who would like to do photorealistic rendering and ray tracing, this is the library to use. The analytics, the AI Analytics Toolkit with a focus on deep learning has the TensorFlow, an optimized TensorFlow implementation in there, an Intel optimized PyTorch version, deep learning version in there. So you have, you have frameworks which are optimized for the various Intel hardware. So whether it's CPU or discrete CPU, GPU, it's already optimized. I talked about the Openvino already here a little bit more detail. So it's another library which consists of different elements. So there's a computer vision set of libraries in there. There are even media libraries in there. So the media SDK is in there with coding, decoding of video codecs. There are APIs in here for writing applications, and as I said, predominantly in the embedded environment for different hardware. That goes, by the way, also beyond discrete graphics and FPGAs and CPUs. Intel has a couple of dedicated visual DSPs, I would say, relatively cost-efficient solutions that were useful on the edge, for instance, in camera solutions, for instance. So I'm pretty much coming to the end of the intro. The Dev Cloud is something that Michael going to talk in a bit more detail in the next couple of minutes. So I'm going to skip over that very quickly. It's a sandbox with hardware and software that you can use. There are a lot of resources which I think are very relevant for those who'd like to start and do significant and intense work on DPC Plus and on oneAPI. There are books, there are a lot of links. Some of the books are also as online version, as free online versions available. Have a look at it. The underlined bullets here are linked to the internet, so there's more information behind it. And as a summary, I'd like to conclude the introductory part. So, as I said, oneAPI is an initiative, it's a standard. Intel has an implementation for it in order to support cross-architectural programming. And for me, and so I'm concluding here on where I started a little bit earlier with the goals of this virtual workshop. I hope that many of you are interested, and you're probably interested, otherwise you wouldn't listen to the two-day workshop. But I would like to entice you to consider transitioning your Preiss Studio XE implementation or solution to the oneAPI toolkits, and ideally also start with developing and porting applications for heterogeneous environments. So with having said that, I'd like to move into a session and hand over to my colleague, Michael Steyer, who's going to talk about the specific MPI features for oneAPI.